Good morning, everyone. Today, inshallah, we will continue in the previous lecture. I want you to remember that in the previous lecture, we already had the following. We did go through the row operations, if you remember them. محمد فاكرهم؟ 3 row operations اللي احنا اتكلمنا عليهم. Okay, step by step. First of all, the row operations, they have a reason. The reason is to get an equivalent form to any matrix that you will face when you see. The 3 main row operations, and I will talk about them today also, and I will continue within the next lectures, are the first of them is row switching. Simplest. You are allowed to replace the rows if you like.
عايزه الموفي عشان عايزه
ما اقدرش اتحرك عشان الكاميرا عشان الكهرباء. رقم 2 رو مالتيبليكيشن. لا مش تقعدي هنا، يا ريت تكتبي.
مش هشوف كويس
هداري عليك الضغط بس. انا هداري عليك الضغط. او هاتي الكرسي واقعدي هنا، بس حاولي تقعدي في مكان ما بقاش انا بداري عليك. اوكي؟ رو مالتيبليكيشن. يعني if you have to multiply a whole row by a fixed number, just do it. It's okay. You will get an equivalent row, so it's okay. The last one is the row addition. You are allowed to add 2 rows to each other. Even though you can multiply one row by a constant number, then you will add it to another row. These 3 operations are really very important. You need to perfect them to minimize the possibility of an error in solving such problems. Okay, perfect. We will continue as I told you. Now I will have to go through some slides confirming on these processes. So please follow. Then I will give an exercise and we will solve it together. Okay? The first thing, or by the end of the previous lecture, we really did go through what's called the echelon form. Here, every matrix A belongs to the general form of matrices of number of rows n, number of columns n, in any number, whatever the numbers, is row equivalent to a matrix in a row echelon form. يعني ايه؟ يعني اي ماتريكس بالشكل العادي اللي انت عارفها انا ممكن احولها لاشلون فورم. محمد انت فاكر ايه هو الاشلون فورم؟ الاشلون فورم دي هي الماتريكس اللي هي اكنها upper triangular matrix. All the numbers below the diagonal line, if exist, if it is a square matrix, should be equal to 0. Okay, bottom line, if you have a complete row of zeros, just move it to the bottom of this matrix. Then you will have your echelon. Okay, so any matrix whatsoever, any matrix whatsoever, I can change it to an equivalent matrix on the echelon form, but using the row operations that I told you about. Here he's talking about the algorithm by itself, how to change to an echelon form. So he's giving you the steps. If the matrix is all zeros, it's in the echelon form. So if you have a null matrix, it's in echelon form. If you have a row matrix with all zeros in this row, it's in echelon form. Otherwise, stated here, the first one is to replace the row. This is operation number 1. Maybe if you like to multiply in the reciprocal or something, maybe you can apply multiplying a row in a number, then adding it to another row. As I told you, the 3 steps that I told you about. Here he's talking to you or telling you the process in order to get an echelon form, which the abbreviation for the echelon form is F.E. And remember this abbreviation. If I want to have a reduced echelon form, it's gonna be F.E.R. Okay? Most of the matrices, all the matrices, can reach an echelon form. But if I have an A, the echelon form, maybe it's not unique. That I can get an echelon form on a form, and you can solve it also and get it to a nearer echelon form. Okay? But it's not exactly the same. But for the reduced echelon form, every matrix has a unique reduced echelon form. Okay? And they are all unique, means every matrix would have just only one. So if I used the operations, and once I use the operations in another way, we will end up having the same reduced echelon form. Okay? Perfect. This, as I told you previously, it already exists on the slides that I sent you. The process by itself It's just for the knowledge and confirming how to do it. Okay, let's look at this matrix. Look at this matrix. The first question, is it on the echelon form? Can say, is it on the echelon form? What's كده? Yes, a complete row of zeros within the bottom, so that's okay. The first entry in any row, the first number that you will face in any row, it starts with a number. The elements on the left are zeros. So remark, the first row, the first number that I will hit is a number. All the remaining numbers exist on the right. Let's go for the second row. The second row, the first number that I will hit, which is 1. All the numbers are behind it, to the right. Same way like for the third row. So it is on the echelon. So this matrix is in F.E form. I need to transform it to be on the FER form. So I will continue the 3 process that I told you about in order to put it on the reduced form. How to be on the reduced form? The elements that you need, the first element in each row should just only to be the number, and the column that contains this number, all the elements should be 0. Okay? So let's try to adjust. The first of them, the first row is correct. The first row is correct for the reduced form. Because once you enter, you will hit 1. Look to the column. The remaining numbers are zeros. Okay, let's go for the second row. The second row, the first number that I hit is 1. Still, there is number above this value. So I will try to erase it. How to erase 2? How to make it equal to 0? Okay, I will have to stand by this number, which is 1, which is called a pivot of this row. And then, please, I will multiply this number by exactly the same value, but with opposite sign. Then I will add this row on the above row. Okay, once more. The first row that I want to change its values in the second. So I'm going to write it first. So the first row that will be written, Ya Ibrahim, the second row, which is 0, 0, 1, -1, and 0. Okay, perfect. I need this number to be 0, but instead of 0 I have 2. So what I'm going to do, I will multiply this row in my mind in -2 zeta, starting from the first number. Let's multiply. -2 times 0 is going to be Ibrahim. -2 times 0 is going to be 0 plus 0. So this value is 0. Repeated once more. -2 times 0 plus 1, so it's going to be 1. This is what? -2 times 1 is going to be -2. Plus at 2, so the result will be 0. This is what I want. Then -2 times -1 is going to be positive. 2 plus 1, so it's going to come up to 3. Stay on the same track, Ahmed. -2 times 0 is going to be 0 plus -1, so the result will be negative. بنسيك once more. احنا عامل ايه؟ يوسف لورا خليك معايا كده مشيت خلاص. تاني انا ببص على اي ماتريكس انا عايزها تبقى reduced form على طول. النمبرز اللي exist the first entry in each row should equal to +1. I already have it. This is +1, this is +1. Okay, the first entry is 1. The remaining numbers in this column is equal to 0. Okay, so the first one is a very good shape. I will go to the second row. The first entry is 1. Look to the column. The column still has +2. How to replace it? معايا زينة ازاي اغير ال 2 واخليها 0. خلي بالك اللي بيسألني بملتبلاي ال +1 البيفوت by the same number but with opposite sign in my mind. Then I will add it. So what number do you need to equal to 0? 2. So mainly I will multiply 1 in 2 but with negative sign. So I will multiply -2. Once you multiply, you start from the first of the row till the end of it. Multiplying then adding. Let's do it once more. هعمله تاني كمان مرة. لأن ده مهم. لو أنت فهمت خلاص. times 0 is gonna be 0. Plus 0, so it 0. Negative 2 times 0 plus 1.
1.
Negative 2 plus 2, so the result will be 0. Negative 2 times negative 1, it's gonna be positive 2. Plus 1, so it will be negative 2 times 0 is gonna equal to 0. Plus negative 1, so it will be okay. Look to this one, to this number. All the remaining numbers are zeros, so it's perfect. Okay, I will start. This is okay. I will go for the matrix. I will complete it. So it's 0, 0, then 0, 0, then 3. The last row is zeros. This is done. This is for the second matrix. Go for the third row. Go for the third row.
First number 3.
The first entry is
3.
I don't need it to be 3. I need this number to be positive 1. This is for FER. Okay. Why we need it to be positive 1? Later, عشان يبقى easier down the road to change this number to become a 0. So the first thing that I will do right now is to focus on this row. So I'm going to write it once more. See? I'm going to write it once more. This is a new matrix. I will write this row. But before I write it, I need 3 to equal to change to be 1. So I will choose to multiply R3 dash will equal to 1 over 3 times R3. Which means I will choose the third row and I will change it by multiplying the whole row by 1 over 3. Row R1, R2, R3. Okay? So I will multiply R3 and 1 over 3. Why do this? Multiply. And the row that you will do this operation on it is the first row. It is the first row that you write. Okay, let's do it. So it's a 0, then 0, then 0, 0, and positive. Done. Okay? So, measure it. Thank you, sir. Okay, same way like. بص على البوزيتيف 1. The elements blue positive 1, the third row, is already 0. So I'm not going to accept any of it. I will write it down. The numbers above 1 is also 0. So this row is correct. 0, negative 1, positive 1, and then double zeros. The first row is not correct. The first row contains, and I want it to be 0. What to do it? The general case, the systematic steps. I will multiply this number by exactly that number, what was opposite side. So actually, I will multiply the third row in positive 1, and then I will add it on the first row. Or just add them together. But I'm trying to make the steps for you systematic, without thinking. So I will multiply 1. 1 times 0 is equal to 0 plus 0, so the result will be 0. 1 times 0 equal to 0 plus 1. Okay, you succeeded in keeping that 1, and I need it. Then 1 times 0 is going to be equal to 0 plus 0, so it's 0. 1 times 0 is going to equal to 0 plus 3. I don't have to change it. The last one. 1 times 1 equal to 1 plus negative 1, so the result will be 0. Remark. In each row, the first entry is positive 1. And the remaining elements in this row equal to what? To 0. So, the first one is complete 0, which is okay. The first number I had, 1. The remaining numbers are 0. Once more, for the third row. The first number that I will hit is positive 1. The remaining numbers are zeros. So now I've reached the FER. FER4, or what's called the reduced echelon form. Ahmed, I started this problem by multiplying the second row negative 2, then adding it to the first row. Layla may suggest that I need to change the 3 first. It's up to me. I will multiply first the third row 1 over 3. It's correct. Okay? If we are seeking echelon form, maybe mine will be different than yours. for the echelon form. But for the reduced echelon form, whatever the way you are using or the method, as long as you are doing it right, we will end up having this form. Okay? To prove this, remember the steps. I've already multiplied in -2 and added. And then down the road, I've multiplied by 1 over 3. Yes? Okay. خليك معايا. I will erase all of these. It's already recorded and you have it. Okay? Let me see on the slides how they get the FA. Okay, look at them. See, the first step that hit my mind or that hit my eyes, the third row contained 3. And I want to change it, so I will choose to multiply by 1 over 3. Okay, so they didn't do exactly the same steps that I used. Okay, he changed this one. Okay, perfect. And then he did what? Okay, I need to remove this number 1, -1. So I simply will multiply this by 1 and adding it on the first row, or add them together. See, this is the last step. He adjusted the last column. Then remaining the second one is not all zeros about the difference. حضرتك فاهمني؟ So he chose to finally multiply this by -2 and add it to the first row. So the process different, but the result exactly. This is for the reduced echelon. Okay, what I need from you, please, I want you to do exactly what I did on this example in home and try it by yourself. Okay? It needs training and the practice using your hand, writing it.
You don't have quizzes?
You will have, but not in the topic. Okay. And you have forms on Moodle once Moodle open for you.
هو هيشتغل امتى اصلا؟
طيب خلي الاسئله دي بعدين نعمل بريكورد ده وقت. وعايز الستبس بتاعته تبقى قدامك واضحه واضحه. اوكي؟ هنا بيقول لك في يونيكنس، انا قلت لك على reduced echelon forms are unique. Either you do it, you replace the steps, but you will end up having the same A double dash, which is on the reduced echelon form. Perfect. Okay, for A, okay. He's stating here let A goes to M by the reduced row echelon. يعني لو انا مشيت نفس الستبس اللي انت شفتها ورا in order to get the nearest shape to a unit matrix. بيقول لك of A or ممكن اقول عليه reduced echelon form ممكن اقول عليه hermit form. So this definition is important. If you hear hermit form, it's a reduced echelon form. The process that you use in order to get to reduce echelon form. So this definition is important. We need the unit matrix row equivalent to A and in a reduced echelon form. The matrices A and B are row equivalent. الاثنين دول equivalent لبعض. F and only F. بالظبط يحصل امتى؟ خلي بالك. If they have the same reduced row echelon form. يعني if I have two matrices and I walk the process in order to get to the reduced echelon form, and these two matrices ended exactly the same, so they are equivalent to each other. Okay? Here he is stating the them for you. I will draw it for the time being. You can look at it in the slides, and I've already sent it to you. Also, this is okay. This is the problem that I want you to look at. بص بقى ورا أنا عندي two matrices. This is maybe a good question. Are these two matrices equivalent to each other? How to know if they are equivalent or not? Try to put them on the FER form or the Hermit form or the reduced echelon form. Let's see for the first one. For the first matrix, I will try to do it here. Okay, I need this matrix to be in the reduced echelon form. Layla, the first thing that I will do, what to do? The first thing, I've started the first row, which is 2. I need this 2 to equal to 1. So I will divide the first row by 2. Divide by 2 or multiply by half. They are the same. So I will have 1, then 1, then 1. Okay, I can write it like this. I can write that R1 dash, which is the new one, equal exactly half of the R1 in the old matrix. الجميل الستيب اللي بعديها هنزل على السكند رو. Second row starts with all zeros. The first entry is 1. Okay, this is perfect. But is it the only one in its column? No. So I will have to make an extra step. Then I will multiply this by -1 and I will add it to the first row. So I will do it here. Okay? Multiply by -1 and add on the other row. So it's gonna be 0, 0, and 1. This is the pivot of this row. Multiply -1. -1 times 0 is gonna be 0 plus 1, it's 1. -1 times 0 equal to 0 plus 1, so it's 1. -1 plus 1, so it's 0. This is the FDR for the first matrix. No. If it contains all zeros, you will leave it as it is. Okay? But if contains a number, you should check that number equal to +1. And the remaining elements in this column equal to what? To 0. Okay. I will use my red pen for the second matrix. Okay, start with me. Okay, for the second matrix. ايه؟ مش فاهم ايه؟ طب اعمل معاك تاني يوسف. انا عايز احطها على الريديوسد فوق. عيد نفس الستبس. اول فيرست معلش واحده. اول ستيب the first row will be starting with 1. Was okay for me. I will write it down. So the first row is okay. 1, then 2, then 0. That's the first row. Okay, I need this +1 to be the only number in its column. Column that is equal to zeros. But still you have 1. How to replace this one using the 3 row operations that I told you about in the beginning of this lecture or in the previous one in order to change it to be 0. How to do this? Times -1, then adding on it. Okay, start. -1 plus +1, the result will be 0. Okay, -1 times 2, so it's going to be -2 plus 2, so the result will be -1 times 0 is going to be 0 plus 1, so the result will be 1. Okay, the first row is well established. The second row also very good. The first entry is +1. The remaining elements are zeros. So actually, this matrix, this is the FER of the second one.
Can we divide the first row?
Okay, just look at the second page. Look to this one. This is the FER of the second, of the first one. Are they the same? 1, 0, 1, 0. This is 1, this is 2. They are not the same. They are not what? The same. So, in order to have these matrices equivalent to each other, if I work it out, this matrix, to reach the reduced echelon form, should be identical in each element, in each row, everything to the other one. Okay, once more, here we go. This is a double dash, which is the FER, 1100001. For the other matrix, it's 120, 00, and 1, so they are different than each other, so it's correct. They are not row equivalent because F, A double dash, is the reduced echelon form from A, and B double dash is the reduced row echelon forms of B. Then they will be equivalent to each other, but they are different. So these two matrices are not echelon form. Are not equivalent to each other. Okay? تمام؟ اوكي؟ ماشي. تعالى الاكزامبل ده كويس علشان بوري لك الرو اوبريشنز. يوسف احنا هنعمل plenty of row operations just in a few seconds. So just wait with me and we will do it more than once. Okay, go. I want to define what's a rank. The rank in a matrix is really very important. The rank is defined simply as the number of non-zero rows. يعني ايه zero row? A row that contains zeros from the beginning till the end of it. That's what's called a zero. يبقى بالتالي كمان مرة زينا يعني ايه rank؟ Number of non-zero rows in a matrix. Number of non-zero rows in a matrix in the reduced echelon form or in the echelon form. يبقى أنا if I give you a matrix and you want to know the rank of that matrix, just try to play with the three things that I told you about: replacing rows, multiplying the row by a number, multiplying the row by a number, and then adding it to another row in order to get it to the echelon form. Okay? We will have a theorem here stating that the rank of a matrix exactly equal the same for a rank of its equivalent matrix in echelon form. So this is what's called a rank of a matrix. So the rank of A denoted by R of A. So if you see R of A means the rank. If the number of, okay, non-zeros of a matrix, row equivalent to what? To A. In which form? In the echelon form. So maybe at the beginning you will see two different matrices. Okay? But if you try to work this out and that one out to reach the echelon form, you may find that this matrix with a rank of 3, but the other matrix is a rank of 2. One of them disappeared for some reason, and this will appear downward. Okay? Perfect. The definition of the rank is important because it will go with you with the classification of matrix solution of system of a linear system of equations. Here he is stating to you that if I have an A, which is a matrix with m rows and n columns, the rank will be less than or equal to the least number of both of them. So if I have a matrix is 3 by 4, could the rank be 4? No. It should equal to the least, less than or equal to the list of these two numbers. So it's going to be less than or equal to what? To 3. 3 and this. So this definition is written here and put. Okay, if I have an A and he's stating that, okay, the elementary row operations don't change the rank. So if you multiply a row by a number, if you add another row, if you repeat the rows, the rank is not going to be changed. Which almost the same as we said before. That theorem is very, very important. Remark, let A belongs to n by n. What we mean by n by n?
Square matrix.
Square matrix. The following statements are equivalent. So, in the previous slides, Yusuf, he was talking in general for any matrix, n by n. But now, I am exactly talking about the square matrices, which have the number of rows equal to the number of columns. This is not negotiable now. Okay, A is invertible, number 1. Okay, let A be an element, the following statements are equivalent. A is an invertible, لو ال A invertible. Rank of A equal to n. يعني لازم الرانك بتاع ال A equal the number of A of its rows. IN is the reduced echelon form for A. يبقى الماتريكس اللي فاتت اللي انت شفتها it was not a square matrix اللي احنا عملناه الاكزامبل اللي احنا عملناه. الاكزامبل اللي احنا عملناه ده I think كان 4 rows and 5 columns as I remember. Yes? So we didn't hit I. لكن for the square matrices the reduced echelon form will be unit matrix. Okay, A is a product of elementary matrices. I will tell you about elementary matrices in details just in a few seconds. Remark about this. A is invertible and the rank should, if A is invertible, the rank should equal to the number of rows. The rank should equal to number of rows. Okay. بص بقى سيب لي كده خالص عايز افهمك الحته دي وبعد كده هنحل بسرعه على طول. تمام؟ And I need to reach the reduced echelon form. I need to reach the reduced echelon form. By logic, this is A. I made some changes. One of the 3 changes that I told you about. This was the first change to A. I made another change in order to get A1. I'm doing all of this in order to change this matrix to be the identity matrix. Wait. We had previously, if I have 2 matrices and I multiply them together and the result is equal to the unit matrix, it's the inverse. You are multiplying a matrix by its inverse. So once more, if I have matrix A and I will start by the row operations, in my mind, I needed to reach the unit matrix. All these process that you are using, if you multiply or you sum all of these processes together, actually you are multiplying the A matrix by its inverse. So if I choose each one of these matrices to be an elementary matrix, which are the ones that I will show you in a few seconds, and I start multiplying, this is the first row operation matrix, the second operation matrix, the third operation matrix, and so on, elementary matrix, I'm sorry, till you change A to be I, this is the inverse. This is the introduction of how to get an inverse from a matrix in by N. By doing the row operation matrices. It's exactly like multiplying A in its inverse. So, if I suggest that I equal to the elementary matrices times A, so the multiplication of all of these elementary matrices will lead to A minus 1. So now we know that A minus 1 is the multiplication of all the process that you did in order to reach the reduced echelon. This is the definition, or this is why we will use the row operation methods in order to get an inverse. Okay, I hope you understand this. This matrix. I'm sorry. These steps. From the previous slide, if I want to get an inverse for a matrix, خلي بالك بقى. كل اللي انا عليا اعمله زي I will write this matrix, which states A, then I will have what's called an equivalent line, and I will work the row operations, the main operations that we did. If I succeed in transforming A into unit matrix, all the processes that I did, it's gonna develop the inverse matrix that you are aiming for. So if I want to get an inverse, so the previous slide, all what I said in the previous slide is to make you able to use this form in order to get an inverse. ما تقومش دلوقتي. يا ريت. It's up to you. We make elementary row operations in A until we get IN. If in IN we make the same sequence of elementary row operation, then we'll take A minus 1. انا لو جمعت كل البروسيس اللي انت شفتها من شويه عشان اوصل للريديوست ايشلون فورم، يبقى كده على طول انا جبت مين؟ الانفرس. اوكي. خليني ابص عليها، انا عايز اعملها لك. هنا بيسالك بيقول ايه؟ First we will see if A is invertible or not. For any matrix in the previous slide, I've told you that if I have a square matrix and if the rank equal to the number of rows, this matrix is invertible. طيب, how to get the rank? I will get the rank if I get the echelon 4 and I count the number of non-zero rows, and we will find them equal to the number of rows in this matrix, so it's invertible. Okay, تعالوا معايا كده. المسألة دي this problem I will solve it twice. The first one, or the first problem, to see if it is invertible or not. Let's say, how to know it is invertible? I will try to reach the echelon 4. If the echelon 4 become to 3 non-zero rows, so the rank is 3, which equal to the number of, so it is invertible. Okay? Once more, I need to check if this matrix is invertible or not. How to check that? I will have to go to change this matrix to be on the echelon 4. If I succeeded in replacing this matrix using the row operation into the echelon 4, then I will count the number of non-zero rows. If they are 3 exactly like these 3 rows, so this matrix is invertible. That means you can get its inverse.
دكتور يعني المفروض لو في زيروز يعني في كلها؟
لا مش زيروز كلها. لو مش كل الرو كله زيرو. الايشلون فورم احنا بنعملها ازاي؟
ديجيت واحد وباقي كله زيرو.
ده الريديوس ايشلون فورم. لكن الايشلون فورم اول رقم تشوفيه في الانتري في اي بس. خلاص تعالى بقى نعمل ده. اوكي. يبقى انا دلوقتي I will focus to change this matrix into its echelon. Then I will count the number of of rows. معايا يوسف؟ يلا خليك مع محمد. خليك معايا. أول step
101.
ما تقدرش تعمل كده. أول step the first row should equal to a number. So the first row, the first number is 1. Okay, I will. So it's gonna be 1, 0, and 1. For the first row, I would suggest in all times try to make it equal to positive 1. If not equal to positive 1, try to see if you can adjust it to be positive 1. So this one is already adjusted. Once the first entry is a number, I need the remaining elements in this column to equal to zeros. How to do it equal to zeros? I will use my other pen. Yusuf. I need this 2, Zaina. I need this 2 to appear here as a 0. What to do?
أعمل times 2.
Zaina.
times 2.
قولي. I will multiply 1 by the same number but with opposite sign in my mind. Then I will add. This is how to make a 0. Let's try it once more. كلامك صح once again. Negative 2 times 1 equal negative 2. معايا إبراهيم؟ Plus 2, so the result will be?
0.
Repeat it يا عم. Negative 2 times 0 is going to be 0. Plus 2 is going to be 2. Negative 2 times 1 is going to be negative 2. Added on a positive 2, so the result will be 0. I succeeded in transforming the first element or the second element in this column to equal to 0. Still, I will need this number. But this number is negative 1. How to force this value, Yusuf? Let it equal to 0. I can add them together. 1 plus negative 1 is going to be 0. That means I will add all of them. Okay, ممكن أعمل كده. I will multiply the first number in positive 1, then I will add it on negative 1. So the result will be repeated. 1 times 0 equal to 0 plus 0, so it's going to be 0. 1 times, okay, I'm multiplying it positive 1. 1 times 1, it's positive 1 plus 0, so this number is 1. يبقى تاني once more. 1 plus negative 1 equal to 0, 0 plus 0 is equal to 0, 1 plus 0 equal to 1. Look to the first account, it's already adjusted. A number, then the rest of the elements equal to 0.
تمام معلش.
Okay.
احنا ناخد أول رو هو التوتال بتاعتي.
تمام.
وأبدأ بقى أحسب عليهم
عليه هو. دلوقتي أنا كده ظبطت الفيرست column صح؟ تعالي بصي على السكند column. Second column I'm doing the additional 4. So the